In the previous movie, we added the ability to stretch both the IK and FK arms. In this movie, we'll create an elbow control for the IK arm. Start by opening the file Character Rigging, Part 24 Start, or by using your own file from the previous lesson. As you may recall from rigging the leg in Part 14, we created a pole vector constraint for the leg's IK handle to point the knee at the locator. We also developed a no-flip solution where we set up a knee twist attribute to orient the knee, and by extension the leg, to facilitate animating certain motions, such as walk cycles. However, because of the wide range of movement for the arm, an animator will usually want direct control over the elbow's twist. Therefore, a no-flip solution wouldn't be very useful, so we aren't going to bother worrying about it. This simplifies our rig requirements considerably, because we only need to deal with this one IK arm instead of implementing a dual IK arm system. Let's start by creating the elbow control itself. Create a locator and rename it Left Elbow Loc. Point snap it to the forearm joint and then translate it back a bit in Z. Select the locator, then the left arm handle, and select Constrain Pole Vector. We can now aim the elbow by moving the locator. Just like the knee though, we'd prefer to have a NURBS curve control rather than this locator to stay consistent with the rest of our controls. Since the elbow and the knee are so similar in function, let's use the left knee control as reference. Select the left knee control and go to Edit, Duplicate Special. Reset the settings and then switch the Group Under option to World. This will reparent the duplicate to the world so we can find it easily. Rename the curve Left Elbow Control and delete all its child nodes. Let's also remove this control from the leg's IK layer and instead add it to the arm's IK layer. Just like the arm IK control, we want to center this control at 0. Grid snap it to the origin, then freeze its translation. Since the elbow faces the opposite direction from the knee, we actually need to select all the control vertices at its tip and pull them to the other side so it points the correct way. Point snap the curve to the left elbow lock and then parent the locator under the curve. Save your new control's transform preset as Left Elbow Control Bind. Great, now we have a working elbow. Next, let's work on a snap attribute. You'll remember that we set up this functionality in Part 16 to pin the knee in place and animate the rest of the body around it. Here we'd like to mimic that functionality for the elbow. We'll accomplish this as we did before, by scaling the upper arm and forearm IK joints to meet the left elbow control. First, use the distance tool to create two measurements, one with the upper arm joint to the left elbow control, and another from the left elbow control to the hand joint. Rename them appropriately. We'll also need to parent them to the appropriate controls so the distances adjust correctly. Now that we know these distances, we just need to extend the upper arm and forearm to the elbow control when appropriate. First, let's remove the knee snap attribute from the elbow control and replace it with an elbow snap attribute. Select the left forearm IK joint, left upper arm to elbow distance node, and left elbow control. Open the node editor and display the connections. Remember, we want to choose between the upper arm stretching according to the overall arm length versus the elbow snap. Create a blend colors node and rename it left upper arm stretch choice. Use the left elbow control's snap attribute to drive the blender attribute. Now we want to blend between either the entire arm length or the upper arm to elbow distance. So feed the left upper arm to elbow distance shape node's distance attribute into the blend node's color1R. Then feed the left forearm IK joint driven key animation node's output into the blend node's color2R. Finally, feed the output R of that blend node into the translate X attribute of the forearm IK joint. We'll have to do the same thing for the forearm using the animation curve of the hand joint. Excellent! Now we can plant the elbow and move the hand and body around it. As always, we'll hide all the locators and distance nodes. Now, as nice as this is, there is a case we should consider that differs from the knee. Because of the leg's typical range of motion, movement of the shin tends to be quite limited once the knee is planted. Any situation where it can move would be more easily handled in FK mode anyway. However, for the arm, there's all kinds of movement we can do when the elbow is pinned. For example, we can bring the arm up to rest our head in it, bring it down to grab an object on a table, or even move back and forth in a heated arm wrestle. However, many of these movements don't lend themselves well to an imprecise IK control. In the next movie, we'll outfit our IK elbow control with an FK forearm to make these kinds of movements easier for the animator.